Alright, this is day 5, proving segment relationships. What you see here that you need to copy into your notes is a segment addition postulate. It's a really common one to use, that if you have a point between two other points, then the addition of the two smaller segments will equal the whole. And that's represented with AB plus BC equals the whole segment, AC. Now, I'm going to do a few proofs for you. My suggestion would be that you probably pause the video at the beginning, see what you could do for yourself, and then I'll just show the whole proof and explain the steps I got. So here's this first example, and I'll go ahead and show that in just a moment. And where I would start after the given would be to show that AB equals CD, and that is by definition of congruent segments. And I'm going to do that because I'm going to be dealing with measures. I'm always going to stay focused on what I'm trying to prove, and I'm going to show that AC is the same as BD. To do that, I'll break down AC and BD. That AC is equal to AB plus BC, and that's by segment addition postulate. Similar reasoning could make me get that BD, from what I'm trying to prove, is equal to BC plus CD. Now, what I'm trying to prove is the same, does not equal the same thing right now. The BCs are in common. So what I'm going to do is I'm going to take the AB here, I'm going to replace it with CD since it's equal to AB. So for statement number 4, I'm taking this AC equation, AC equals, I'm going to change the AB to CD, CD plus BC. And that's by a substitution property. Now I've got that AC is equal to CD plus BC. BD is equal to the same thing. They do now equal each other by transitive property. So my statement 5 will be that AC equals BD by transitive property. And then once I've gotten that, I'm going to actually just use a definition of congruent segments again to say that the segments themselves would be congruent. I do need that last step 6 there to actually say that segments are congruent by definition of congruent segments. I had that their measures were equal, so they are congruent. That wraps up this proof. Alright, on this proof I've already set up the given into my proof. I'm trying to get the fact that AE is congruent to GD. Now, looking at the given, where I would start with this proof is I would actually go ahead and state that segment GD would be congruent to segment FH since they are both congruent to segment BC. That would be by transitive property. Then I would go ahead and take a look at the proofs now. You can see that sorry, I miswrote that. That should have been FH right there, because they're both congruent to BC. Alright, now looking at segment AE and segment GD, they are both congruent to segment FH, so they're going to be congruent to each other by transitive property yet again. Now I'm actually done with the proof. So segment AE is congruent to segment GD, and that's transitive property again. So sometimes proofs are very straightforward and easy to do. If you had listed this in the wrong order, you'd said segment GD is congruent to segment AE, you'd have to add another step here of flopping it to what it needs to be, and that would be by symmetric property if ever you need to do that. Alright, so on this one you're given is that E is the midpoint of segment DF and segment CD is congruent to segment FG. We're trying to prove that segment CE is congruent to segment EG. You can see that point H really is not going to be a player in this. That's just kind of there for no reason. You really just need the top line segment. So I'm going to go ahead and set this up and get going. So I'm looking at CE and looking at EG, and I'm probably going to use segment addition postulate. I'm going to have to do this by measures. So for my second step, what I'm actually going to do is go ahead and use definition of congruent segments to say that CD is equal to FG, talking about a measure. There I have definition of congruent segments. For statement 3, what I would do is apply the fact that E is the midpoint of segment DF. That tells me that DE and EF are the same, so I'm going to say DE equals EF by midpoint definition. Okay, definition of a midpoint. It would not be midpoint theorem since I was talking about the measures. If you're talking about the measures, you're talking about the definition of a midpoint. If you're talking about the segments being congruent, then you're talking about the midpoint theorem. Now, moving forward, let's go ahead and state what CE and EG are equal to, since that's what I'm trying to prove something about. For statement 4, CE would equal CD plus EG, or CD plus DE, sorry. And that's my segment addition postulate. Similarly, EG is going to equal EF plus FG. Both of those by segment addition postulate. Now I'm going to have to pick up over here at the top left. For statement 5, what I would do is I would actually try to get these to match up, and I can by, for instance, taking the CD, changing it to an FG, and then taking the DE, changing it to an EF, then CE and EG will equal the same thing, EF plus FG. So I'm going to show that CE is equal to, like I said, change the CD to an FG, plus change the DE to an EF, and what I just used was substitution property. So substitution property. And then now that I've got them equal to FG plus EF on both CE and EG, CE and EG would equal one another by transitive property. And then they would be congruent segments because their measures were equal by definition of congruent segments. Sorry, I ran out of space on this one. So definition of congruent segments would wrap this proof up. All right, and there it is. Everything's wrapped up and done, 7 steps, and we're finished with notes. Please let me know what questions you got.